Thanks, Paul. Okay, I tend to wander, so I'm not going to stand behind the podium today. One, thanks for the introduction that my mom would have been proud of. That was great. Right, the flip side is I'm a bit of fish out of water here with all the strong Navy contingent, but I'm okay. I brought backup. He's over there in the corner, and he's scrappy. So seriously, thank you for the opportunity. I think every occasion that we have to engage in this dialogue and discussion is one that moves us collectively further forward. And I resonated actually with a number of the points that the last panel made on that topic. It really is a team sport. It's full contact, and it has the opportunity to create grievous bodily harm here if we don't get it right. So I get asked often, hey, what exactly is it that you do? I break things and kill stuff, okay? And I think too often on the acquisition side of it, we get enamored with cost, schedule, and performance, and we'll throw in some risk occasionally, but that's not why we do what we do, okay? We do what we do to win wars. And I think the closer you stay to that fact and the specific operational problem that you need to figure out how to solve, the more likely we are to actually get it done in a time frame and in a manner that makes a difference. So the topic is innovation, and what I'm going to do is I'm going to give you 3 points. I didn't bring any slides. I figured everybody's eating and you'd rather get down to business. So I'm going to talk to you a little bit about complexity and how we manage that. I'm going to talk to you about capabilities and what those capabilities need to look like as we're moving forward, and then I'm going to talk to you about culture. Okay, but I want to put that in the context of the topic here, which is innovation. Unlike the esteemed panel that we had up here just previous, I actually went to the school a little bit further down the Charles River, a place called Massachusetts Institute of Technology. The Harvard guys were fun. They did their case studies. We did the real engineering. Okay. I had to get that dig out. So it's out of my system. Okay. So one thing that I will tell you from some of those core innovation courses that I took up at MIT, and that I'm playing out in spades now, is that innovation does not happen in the abstract. It does not happen in a vacuum. And in order to make the kinds of things happen that you need to inside of an innovation ecosystem, you need a couple of key ingredients. One, you need a really wicked good understanding of the problem you're trying to solve. Okay, and the sharper you can focus that, the more likely you are to get something that's going to make a difference. Okay. The second piece that you need is you really need the intersection of I call it the intersection of dissimilar bodies of information. Okay, how are you going to get new ideas and new thinking into that space around that problem? Okay, and how are you going to do that in a way that's more than just a random collision that happens by serendipity? You need to actually plan how that's going to happen if you want it to actually turn over, roll over, and make progress over time. Okay. So I need a really good definition of the problem. I need a way of pulling in dissimilar information into that environment. And then I need some really, really hard constraints that I have to go out and figure out how to maneuver my way around. If you put those 3 ingredients all into the pot and you mix it up, you're much more likely to get some innovation out of the back end than you would have, right? You just got lucky, okay? There's an old adage, right? It's better to be lucky than good. But the better you are, the luckier you get, okay? So these things aren't unrelated to each other. Yeah, a little bit of luck happens to go a long way. Vulcanized rubber would be a good example, right? But if you're putting those ingredients together, it's much more likely that you're going to get something good out of the back end than if you didn't. So now the question is, what problem are we going to point it at? Okay, and that's where this conversation picks up in terms of my day job. So from a practical standpoint and put the cookies down on the bottom shelf perspective, I am the lightning bolts on everybody's charts. Okay, so for all of you PowerPoint rangers out there that stick lightning bolts on your charts to communicate with, right, I'm going to come find you. Okay, they're not lightning bolts. There's some really hard engineering that has to happen to make all that stuff work. And unfortunately, historically, the department, this is a technical term, has sucked at figuring that out. Okay, And that's why I have the benefit of having the hardest job Secretary Kendall gave everybody, because he's, in fact, if you want to take a trip down memory lane with him, he'll be only too glad to oblige you on all of the C2 programs the department has completely choked on over the last 50 years. And it's an unblemished record of failure, more or less, right? I mean, he'll tell you that. He has told me that. The good news is I only take jobs where the bar is so low there's only one way to go, right? So here we are. And as we're thinking through this, one of the first problems that you have when it comes to, hey, how are you going to stitch together all these disparate weapon systems that somebody built for a rhyme and a reason that doesn't actually care about or otherwise, from an engineering standpoint, was designed to connect with anything else. Like, how are you going to get those to all play together? Okay? And oh, by the way, they were designed for a reason, the way that they were designed, right? I mean, people didn't just make these things up in a vacuum. There was legitimate reasons why they designed them the way that they did. They had some primary function that they had to do, and in the process of doing that primary function, they made a number of engineering design decisions about how that was going to happen. Unfortunately, in the world of organic kill chains, right, we put it all on the platform. It had the sensor, it had the brain, it had the weapons, it had everything it needed. Go kill stuff. Got it. Okay? And make no mistake about it. We have the most exquisite organic kill chains on the planet, bar none. Like, nobody can even come close. The Chinese haven't even figured out how to come close. Okay? We will still clean anybody's clock when it comes to one-on-one organic kill chains. But that's not the world we're living in anymore. Okay? Now, we're living in a world of long-range kill chains and over-the-horizon kind of targeting, killing things that you can't even see, third-party targeting. Right? I mean, you throw all that in the mix, and the complexity in this space goes up as a geometric factor of the number of things that you're trying to play in that space. Okay? If you don't find a way of controlling that level of complexity, it will eat you for lunch. Maybe it even won't wait for lunch. It might just have you for, like, brunch. Okay? It's absolutely critical that level of complexity gets controlled. And the complexity is a combination of the number of things that you're trying to do. It's a combination of the number of different things that you're trying to do. And it's also a factor in the temporal space with regards to how much you're trying to do all at once. Okay, so when you take all three of those things and you want to do a joint fight, you want to do it at scale, and you want to do it at speed against the pacing threat that looks like China, you got a serious problem. You have a serious problem. Some have actually characterized it as probably the most complex endeavor that humankind has ever tried to go figure out how to sort their way through, okay, in terms of the way that you're going to see to that. Now, from a service perspective, we do reasonable jobs within our service enclaves at moving information around. But if you want to move information between services, good luck. Okay, you're usually talking about, two human brains in the same room, one in each a different color of uniform, yelling at each other right across the divider on an ops floor. That's what cross-service communication looks like. Okay, I think we can do better. And in fact, we are doing better. Okay, but if you don't go back to that first principle that I gave you right up front, right, if you don't have a crystal clear picture of the operational problem that you're trying to solve, you'll never achieve the level of alignment that you need across all of those different players in order to get to where you need to end up. Okay, so the picture that the panel up here painted earlier and the threat conversation that you heard from this morning, those all convolve into a very singular focus around a target. So I could spend a ton of money and a lot of time trying to figure out how to connect everything everywhere all the time. Okay, I will tell you right now, for those of you that are wondering, that is absolutely not going to work. We don't have the time, the money, or the wherewithal to do that. So, the question is, well, okay, then how are you going to decide what to connect, when to connect it, and who needs to be connected? What has to die inside of the battle space? Okay, am I killing ships? Am I killing wide bodies? Am I killing fighters? Am I plinking tells? What's the target? Once you tell me the target, and we're all clear about what that target is, right? We can get everybody on the team, Army, Navy, Marine Corps, right? Everybody. Space, okay? You can't do this without the space team. And if you can get them all focused on that same problem, it's actually fairly tractable to manage that level of complexity with regards to, hey, what has to work together in order for that to happen? And if I want it to be more than just a fragile, like, one-off kind of a deal, what would that look like? That you can actually keep your head wrapped around. Okay? So managing the complexity, the way that we're approaching it on the C3VM side of this is we're saying, no. I'm going to go out to the warfighter that's actually got to go fight this. I'm going to go sit down with Indo-PACOM. I'm going to talk them all the way through the vignettes and the scenarios that they're planning on actually employing in the fight. Okay? The comm plan's interesting, but what are you actually going to do? Okay? And then you take that prioritized list of operational objectives that they have and you start with the first one. And if you can't do the first one, don't bother going to the second one. Okay? We have conversations about kill webs. I had a fighter pilot tell me early on in my tenure that the next time I said kill web, he was going to throat punch me because we couldn't even do a single kill chain. He had a point. Okay. You got to be able to do the first thing before you do the second thing, before you do the third thing. Now here's the trick, and this is right. This gets into the way that you think about the way that you actually do the engineering side of this. Okay, you say, okay, great, Cropsey, I'm gonna figure out how to throw it all in on that first target. How do you not paint yourselves into the corner when it comes to the way that you design killing that first target? Because there's 29 right after it. So how do you do that part of the business? Well, this is where we're going to take a departure from the way that we've historically approached this problem from a platform-centric view, and now we're going to take a system of systems view. And I'm going to build an architecture that knows up front that I'm going to continue to expand the problem set one slice at a time as I'm eating into that target deck. And I'm going to build an architecture that is fundamentally wired up so that it stays extensible. Right, you know all the buzzwords, right? We can talk about modular, we can talk about open, we can talk about loosely coupled and highly coherent and okay. And I mean, unless you're a system engineer, all you'll hear is the Charlie Brown voice in the background going wah, 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 wah. Okay, but here's the thing. That actually works if you do it and you do it with discipline, okay? So from a capability, so if that's the complexity part of this, like how do you now like drop this into the capability side? There was a conversation a little bit earlier. You've all heard the old adage that ideas are easy, execution is hard. Okay, execution for the most part is not a technical challenge; it's a human engineering challenge. And in our particular business, it's how do you get the JSIDS process, the acquisition process, and the PBE process to all agree at once on the thing that you're going to go do. And oh, by the way, do that in your lifetime. Or maybe even more relevantly, do it inside of the threats OODA loop evolution, okay? It doesn't know how to do that, especially not in this space. So just to kind of put this in context, right? The majority of the things that I do from a technology standpoint are not invented in DoD, okay? I'm talking about things like compute and networks and it's a lot of that kind of stuff, right? How am I gonna push that kind of capability out and put the right AI? I mean, the whole conversation earlier on AI was pretty good, right? I know I need it. I don't know what the heck it's doing, but I know I need it. Okay, no, trust me. If you don't, I mean, the analogy there on the screens left and right, I think is spot on. We are going to completely crush our operators with data. At the rate that we're moving, okay? We're going to get it piped to where it needs to ultimately go, and it's just going to completely overwhelm the decision makers with regards to all of the inputs that they're getting. They're going to be swimming in it, and that will not be helpful. So the question is, hey, how am I going to take all that data and actually pull out the 5 things that you actually need to be paying attention to and making decisions around? Okay. We're going to need some help there, okay? But in order for that to go from idea to reality, you actually have to create an innovation-friendly acquisition system, and ours is not, okay? My best buddy just took over the Air Force Research Laboratory, and he called me up a few weeks after getting on the job, and he's like, Cropsey, we got good ideas coming out our ears over here. Like, how do I get these things, like, into the, and I'm like, well, we have to have a way of catching them. So all of the great experimentation and prototyping they heard about over here, Task Force 59 style, like, how are you going to move that out of the good idea fairy zone and we'll call it one-off capabilities, and how are you going to scale that? Because to scale it, you need real money in the palm with, right, a PEO that has acquisition authorities from an SAE that is going to move it at scale. Okay? How are you going to do that? And oh, by the way, Palm's 2 years long, right, before you can even start. So the reason you're seeing a lot of the things that you're seeing in the experimentation, the prototyping zone, is because you can get started now. You can use an MTA, middle tier acquisition, or an OTA, other transaction authority, and move. Okay? The question is, how are you going to catch it? And for me, what we're trying to do is we're trying to set up act strategies that look a lot like software pathways. Okay, why? Because fundamentally a software pathway is designed to be a continuous integration, continuous delivery kind of a thing, and you're essentially sizing a pipe that you want to continue year in and year out, regardless of the capability that you're putting in it in the current year. So there's something there to catch what you're throwing at it. Okay, I don't know where the next great app is coming from. I don't know who's going to come up with the next best way to kill whatever the target is that we're looking for tonight. But I need to have an acquisition approach that's basically postured to catch that when it happens, and then rapidly move it into the ops side of that business, which means I also need to think about the rest of the .mil PF. Okay, how am I going to do the training on that stuff? Okay, am I going to create some kind of a standard UI UX so that people aren't having to like relearn the touch and the feel of these things every time? I'm not a digital native, so these kind of things matter to me, but I don't know that my kids would care. So how much does it matter? I mean, these are the kind of conversations that you kind of have to actually figure out as you're going through it with the user. That burn-in conversation is spot on, okay? Just burn it in. Don't do it in theory. Don't you need the digital engineering environment to make sure all this stuff will work together at the end of the day. But the best way to get after it is to actually put it in the field and start kicking the tires. In part because the level of complexity is so high that your ability to predict what's going to happen goes out the window. Like, we're so far past a deterministic system, it's not even funny, okay? At the level of complexity that we're dealing with right now, things are emergent in terms of what happens in the battle space and in terms of what even happens inside of the system, okay? I mean, I can't tell you how often somebody says, oh, I didn't know that would happen. Okay, well, didn't we design the thing? Yeah, we did, but like it's connected to 29 other things, and I can't tell you what those other 29 other things are going to do when it connects to my thing. Okay, let's just go try it, guys. So that prototyping and experimentation piece really gets important when it comes to, hey, how do I move that complexity problem into a space that I can do something with? Okay, but to do that, you have to have an innovation-friendly way of catching those things that will allow you to move it at speed. And that's on the government end of it. On the industry side of it, right, how do you create capability that will bridge into that more seamlessly? Okay, and this is where we owe you a conversation around those architectures. Because if we aren't having a conversation on those architectures, you don't actually know how to do that. And so for instance, I have every 6 months, I hold a TS SCI level conversation with industry on my architectures. So you're not guessing, okay? This is what I'm doing, this is where I'm going, these are the things that we're laying out and we're designing. These are the gaps that we're trying to address. I'm all ears. But it has to be consistent with the architecture, right? The other principle I will tell you is that the architecture will be product spec every day of the week. Now, I have, in fact, incurred some level of wrath from folks in the rest of the enterprise, right, because I got the bright shiny widget that's the best that there is for whatever that bright shiny widget does. But it's vertically integrated, it's stovepiped, it doesn't talk to anything else, It's a proprietary locked-in standard, and right, I say I'm not buying it. Yeah, but Cropsey, you don't understand. I'm like, yeah, no, I understand. Like, I'm the guy in the room with 3 engineering degrees. I understand, okay? And I'm not buying it. Some of those conversations, I'm going to go find somebody else that'll buy it then. Good luck. I don't know how this will last, right? I don't know if I last in this conversation post the secretary, but right now that's holding the water, because if we aren't putting the priority on that architecture and the ability to rapidly move things in and out of it, we lose. Why? Because today's bright shiny object is tomorrow's rust bucket. Okay, with the speed at which the tech is moving, to be honest with you, I don't even spend that much time thinking about what China's doing. I spend a ton of time trying to figure out where commercial industry is going. They are spending billions and billions and billions of dollars every year on the commercial side in this space. Like, we aren't inventing this stuff, okay? The question is, how do I keep up with where the tech is going faster than the Chinese can keep up with the tech is going, because they're not inventing it either, okay? It's a fast, right? We have traditionally in the department done things from a first mover advantage standpoint. I mean, this goes all the way back to the Cold War, okay? I could predict pretty well where the Soviet Union was going to end up. I had a bunch of really good intel, right? Things were big and monolithic. There were very few players. It required a nation-state level of infrastructure, First mover advantage worked great. It's a losing proposition today in this space. There's a lot of players. The tech's moving really fast. It's impossible to predict where it's coming from next. Like, you can't do any of those things, which means I have to have a first mover. I have to have a fast follower architecture that replaces that first mover architecture, and we don't know how to do that as a department. Okay, I call it square peg thinking in a round hole world. Okay, and this gets to the culture piece now, because if you don't have the processes and the people that know how to take that sequence of events and move it into an actual, no kidding, fielded force, you're not going anywhere. You will just fall back down into the same ditch that we operate in from a time sequencing standpoint that we've always used. So the question is, hey, how do you build a culture that is basically antithetical to the way that everybody's been trained for the last 50 years around how to do this business? This is the human engineering side of the problem, okay? And so we've got 3 core values inside of the PEO. The first one is what I call extreme teaming with the entire enterprise. If you think for a minute that we're going to solve it all inside of these 4 walls, you're crazy. We aren't. I can tell you that right now, a priori. It isn't going to be this team that solves it. We're going to help build a team that's going to go solve it, and we're going to have to get really comfortable with the fact that we can pull people in on the team that we don't own. Not in our chain of command, not even in our organization, maybe not even in our service, may not even be in the department. But if they're key to figuring that thing out, go figure out how to get them on the team. Yeah, but boss, we can't tell them what to do. There's a reason extreme is in front of the teaming, okay? If we were just doing the normal thing, it'd just be teaming, okay? You're going to have to really get uncomfortable with the amount of collaboration that gets done in order to make this work. Okay, extreme teaming across the whole enterprise. The second one is make sure that you have a ruthless focus on the operational outcome you're there to achieve. Otherwise, you will not solve the same problem. If you build a team like I just talked about, and that team does not all understand what the problem is that they're there to get figured out, it'll devolve very rapidly into a food fight. Okay. I use Minions a lot because I have 4 kids. Love Minions. They're super clear about bananas. Okay. If Minions are single-minded about bananas, for those of you that haven't seen the cartoons, I'm just going to tell you. So we have a conversation usually, it goes like this. Guys, what problem are we here to solve? And yeah, boss, I know you want it banana simple. Okay. I want it banana simple, and not just because I'm the GO in the room, although I'm sure that's a factor. Okay. I'm if everybody doesn't understand that problem, banana simple, you are not going to get where we need to go on this. And if you can't explain it that clearly, we haven't thought about it hard enough to really get it down to the right brass tacks. So You got to be ruthlessly focused around it, and then every time there's a conversation about whether you go left or right, you go back to that problem, and you ask whether or not going left or right is going to solve that problem better or not. Okay? Extreme teaming, ruthless focus, and the last one, and I caveat this by saying I do not advocate workforce violence. It's violent execution of those priorities. Okay? We have to build a compulsion in our workforce that we're out of time, we're out of money, we're out of options, and right, we darn well better get thinking. This was a great example. This is what violent execution looks like from that last panel. That's taking what you got and figuring out how to use it in new, innovative ways to go kill stuff and break things. That's exactly what I'm talking about. I need that out of my entire workforce. Okay? When I'm pulling in the engineers and the program managers and the logisticians and right, from an acquisition standpoint, I mean, half of them haven't ever actually seen a no kidding for real weapon system that they're working on. Okay, I mean, let that sink in for a minute. Okay. How do you build a culture that looks at what they're doing as winning tomorrow's war today? So that when they show up to work, right, this isn't about a conflict that's going to happen in 27. It's about us going to war right now today so that they have what they need in 27. From an acquisition community standpoint, I'm already way late. Okay, I'm already behind the power curve. So when that workforce walks in the door, are they walking in with their game face on? Or, right, is it just another, right, I'm basically an office job kind of thing, but I do it for the Air Force, or I do it for the Navy, or I pick your service, okay? I intentionally weed those people out. This is a little in your face, like when the boss shows up and says, I'm looking for some violent execution today. I'm like, whoa, that's a little over the top. I'm like, hit the road, Jack. Okay, because if you're not on that oar, and you're not, I'm like a Ben Hur fan here on this one, right? I want ramming speed. Live well, like row well and live kind of a scenario here, okay? We are out of time. If you aren't building that level of urgency and compulsion inside of your workforce, you will not get what you need out of the product. You just won't. Now, the only thing worse than ignorance is ignorance with energy. Okay. Somebody is still awake. You've got to make sure that you do these things in order. I got a teaming mindset. I'm clear about the problem I'm going to go solve, and then I'm going to get busy. If you get busy first, bad things happen. I'm just telling you from experience. I didn't used to have the order the way that I had it. I have that order in the order that I now do for a reason, okay? But if you look across all of the different spaces that you're currently operating in a room this size, I'm sure you're doing everything from BBs to nuclear weapons, okay? That kind of thinking, that kind of mindset, that kind of an approach is going to be fundamental to figuring out how we stitch all this stuff together that will allow us to do system on system and not just platform on platform, okay? The technical problems are tough, but I'd say the harder problem is actually the human side of this. And that starts with a set of expectations and culture around what we do and how we do it. So with that, I will open it up to your poignant questions.